Okay, today we're going to look at the cosine law. We're going to see why we have to use something different instead of just using the sine law that we used before. And the best way to do that is just to try two different examples. If we look at this first one that's on here, it's asking us to find side q. Okay, so using the cosine law, or the sine law, remember you have to have an angle and a side across from it. So the 66 degrees and q are across from each other. So that part's good. And then we need a side and an angle opposite as well. So we have the q over sine 66. If we use the 3.2 side, it's over sine s. Or if we use the 3.1 side, it's over sine r. So you can see in the formula, we get all three sides. We have 3.1 over r, 3.2 over s, q over sine 66. It doesn't matter which two we pick, we're not going to be able to solve it. For example, like if we say let's just pick these two sides. Well, we have an angle r and an angle s. We can't solve for two things in one equation. We can only do one. So that doesn't work. If we picked those two to solve it for side q, then that doesn't work because we can't find angle s, right? We can have two different things that are unknown. So the problem or the issue is when you have an angle stuck between two sides, like we have in the original triangle, right? And a good way to identify it is when you have side, angle, side. I like to say it. So, like for this one, you got a side, you got the angle in between it, and then another side. In that scenario, you'll never be able to use the sine law because we have to have one angle and one side across from it, both numbers given to us. Then after that, we're good to go. So that's the first case that doesn't work. And then the second case, it's similar. When you get a triangle that is, I like to call side, side, side. Okay, so in this case, you can see we have a triangle that has all three sides given to us, but no angles, and it's asking us to find angle F. So once again, if we use the sine law and you set it up, you'd have E over side 2.6, you'd have angle D over the 2.5, and angle F over the 3.6, right? You have to do your opposites, and when we do that, we end up getting the same kind of situation where no matter which two pieces we look at, we're going to have two angles. So in this case, the E and the D are unknown, that doesn't work. We have the D and the F unknown, that doesn't work. Or E and F, that's not going to work. So if you have all three sides given to you, the sine law isn't going to work either. And that's the only two cases. So side, angle, side, or side, 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 that's the two possible cases where sine law isn't going to work, so we're going to have to do something new, and what we use is the cosine law. So let's look at one example of each of how to solve them using the cosine law. So the first case we've got is, I just sketched a triangle here. We've got side 12, side 10, angle 30 in between them, so that's our side, angle, side. And we're looking for that side x. Okay? The way the cosine law is derived, it's basically, if you look at the formulas over here, it looks a lot like Pythagorean theorem, right? If you look at just the first part of that, it looks like Pythagorean theorem. And what we would normally use is a squared plus b squared equals c squared, which is pretty much exactly what we have there. So what we do is we sort of use Pythagorean theorem, and so we find each of those sides, but then we have to do a little bit of SOHCAHTOA, and we have to get rid of that extra little section that doesn't work out. You don't have to know how the formula is arranged, but just to kind of give you a little bit background, it's sort of a spin-off of Pythagorean theorem. Okay, so they have three different formulas that you can use. Just like sine law, we could do A in angle A, B in angle B, C in angle C. The sort of same thing works for cosine law. So you can see that we have, depending on which side we're looking for, if we're looking for side A, then the formula is b squared, so we take side b, square it, plus c squared, side c, square it, then we subtract 2 times b times c times the cosine of angle A. Okay, so in that kind of scenario, if you look at it, it'll work, because we're looking for side A, and we have angle A given to us, side B given to us, and side C given to us. Okay, so it's always going to work no matter what You can use any of the three formulas. They're all exactly the same. It's just depending on whether you're looking for side A, B, or C. What I usually tell everybody to make it easier is we just usually use one formula. So for example, the one that we use most common is the last one, the c squared equals a squared plus b squared minus 2ab cos c. And in that case, if you're going to use just one formula, all you have to do is, no matter what the question is, redraw the triangle so that angle C is the one that you're given and side C is the one that you're looking for. Okay, so then if you change those to C's, and it doesn't matter where you put A and B, let's just put A on top, A on the bottom, angle B, side B, and we're good to go. So now we can actually plug those numbers into the formula. So I'll just rewrite the formula here. So we have c squared equals a squared plus b squared minus 2ab cos c. And those are a, that's all being times. 2 times a times b times cosine of c. Okay? So let's plug the numbers in and see how this one's going to work. So if you take A was our 10 side, so 10 squared. B is 12, so plus 12 squared. And subtract, let's use brackets, 2 times 10 times 12 times cosine of 30. Okay, so on your calculator, just figure all of that out. So just type in exactly the way it is. So let's go 10 squared is 100, plus 12 squared is 144, minus brackets 2 times 10 times 12 times cosine of 30. So that gives us an answer of 36.15. Okay, the only thing you got to be careful now is you didn't solve it for the side that we're looking for. Remember, in the original question we're looking for side C, or X as it was in the original question. We want C. This gave us c squared, so then all we have to do is get rid of that squaring by square rooting. So if we take that answer, square root it, we get 6.01. So let's just round it off to 6, and we're done. So no matter what the question is, if they give you side, angle, side, you just plug all the numbers in the formula, and it's a little bit of a formula to work with, but just type it in on your calculator, get your answer, square root it, and you're done. So the key thing to remember is, no matter what the triangle is, call angle that you're given and or the side that you're looking for, call those C. Always start with the C as being the angle and the side you're looking for. If you do that, the rest of the problem will work pretty simple. Okay, let's try one now where we have side, side, side. So the three formulas I have on this page are all the same. They're exactly the same as what we just did, except they've been rearranged to solve for the angle. So let me just put the old one back on again, just to sort of show you what I mean. So the formula was c squared equals a squared plus b squared minus 2ab cos c. Okay, so what we're looking for is cosine of c. So what they did is they just sort of flipped everything around. So they brought this whole thing to the other side. So by moving it to the other side, it becomes plus. So we have c squared plus 2ab cos c. That equals a squared plus b squared. Then the next step is bring the c squared over, so we have to subtract it. So then we get 2ab cos c equals a squared plus b squared minus c squared. And then the last step is get rid of the 2ab. So we just divide by 2ab, divide by 2ab, so now you see the formula is cos c equals a squared plus b squared minus c squared divided by 2ab, which is exactly what we have given to us. So just like the last question, we can rearrange it for A, B, or C. That's why there's 3 different formulas shown here. But to make things easier, let's do the same rule. Let's always call the side or the angle we're looking for C. If we relabel the triangle that way, then it makes the question a little bit easier to solve. So here we're looking for angle theta, so let's call that one C. So then that means we can call the other ones A and B, and it doesn't matter. You can flip-flop those either way. It'll be the same thing. So then 10 is our side A, 12 is our side B, and 11 is our side C. So now when we plug it into the formula, we get A squared, so that's 10 squared, plus B squared, so that's 12, minus C, which is 11, and we divide by 2 times, let's put that whole thing in brackets, just to make sure the calculator doesn't have any problems. So 2 times 10 times B, which is 12. And that's it. So on your calculator, let's do all of that calculation. So because we're dividing, you want to be a little bit careful in this case. So on your calculator, type in 10 squared plus 12 squared minus 11 squared. Hit equals. So that gives you 123. And then figure out the bottom. So 2 times 10 times 12. That equals 240. So then remember now to solve it for C, we have to go second cos, so go shift cos, 123 divided by 240. Okay, so on your calculator do that, 123 divided by 240 with a shift cos on it. And that gives us an answer of 59.16 degrees. We'll just round it off to 59 degrees. And that's it. So there's the 2 different types of examples that you have to solve for the cosine law. So sine law, remember, you have to have an angle and a side across from it. You have to have both of those given to you. Once you have that, you can solve it for any of the other sides or any of the other angles. But in the cosine law, it takes care of the 2 cases where the sine law doesn't work. When you have side, angle, side, that's where we have to use one of the formulas, and if we always use the C one, it makes it easier. And if we have side, 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 we use one of the cos C formulas, relabel it with the side or the angle being C. Other than that, you're good. Okay, so we'll do a few more practice questions and some assignments, but that's all for today.